Okay, so for today, I think we stopped here, right? Or the free body diagram and everything. So just to do a very quick review, we started discussing on momentum equation. At first, we discussed what does that mean. The momentum equation is like the total momentum should be conserved. Uh, um, and if there are some external forces, so the Newton's second law says that the summation of external forces should be equal to the momentum change in the whole system, right? So for fluid, that's what we will do. And then we came up with the equation, this one, and we simplified that equation for the steady flow and the incompressible fluid. And we said that most of the time we will see this equation because in fluid mechanics here in CE 309, we will not deal with unsteady flow. Everything should be steady. And most of the time we will deal with water or something like that. So that is actually incompressible fluid. So we will use this one, this equation most of the time. So for today's class, the plan is we will work with one class example and we will see how can we identify the different external forces and how can we identify all of these terms from the given values, and we will find out the unknowns. So for class, I uploaded 3 class examples on Canvas, class example 16, 17, 18. So, and I think I didn't review that. Okay. Can we just keep one and pass to others? Okay, so you should have the solution of class example 16 within a few minutes. It's coming to you. And you should have a copy of class example 17 on which we will work today. So class example 16 is something like that, which is pretty straightforward. So I decided to spend more time on class example 17, and you will have the solution for class example 16. Please go through that class example solution, and if you think if you have any confusion or something, we can discuss that on Friday. Okay. So this is the class example 17. We will need time to work on that. So there is a possibility that we'll spend the whole class just to calculate that. But the good thing is for your test, you will not see that much big problem. Obviously, you will get some portion of that problem, but I couldn't find any easier problem for this part. So obvious, that's why we'll work on that. Okay, so bear with me because it will be a little bit long calculation intensive problem and lots of x direction, y direction, cosine, sine, but we will try to work on that slowly so that you get the ideas, okay? And one thing is missing in your question. I didn't identify which part is 1, which part is 2, and which part is 3. So that's what I will do as the first step. So this one is 1, this one is 2, this one is 3. Okay. Please identify your on your copy that this one is 1, 2, 3. And can anyone read the question? Class example 17.
Find the X and Y components of the force needed to hold the following Y pipe flow diversion blade to keep it in place. Use the following table for parameters. Ignore the weight of water.
Thank you very much. So here we have a problem for a flow diversion blade. So flow diversion blade or valve means you can use that like to transfer the fluid from one place to another place in industrial purpose, like in 2 direction you can do that. So this is kind of that type of valve here. The flow is going through point 1 and it is getting divided into 2 parts in 2 and 3. Okay, now just imagine some flow is coming in and something is going out. Obviously the whole pipe can be unstable at a time, right? So this question is asking you to calculate what is the force required to balance all of these forces so that this pipe will be in the place, it will not move. due to this incoming and outgoing force. Okay, so that's what we will try to calculate today. That what force needed to hold the this Y pipe in place, and all the pressure, area, velocity, discharge, density for each point are given. So you don't need to do any calculation on that part. Everything is given. So what we will do, we will try to identify all the known unknowns and knowns, and then we will try to calculate the force which is required to keep the pipe in place. Okay. Now, all of you should have your class lecture from last class. Can you open this page, like procedure for the linear momentum analysis? We will try to follow this step. There are 3 steps, and we will try to follow that one. Okay. Okay. So, as our first step, we need. I'm not writing all the given and unknowns because it's already given, and if I start writing that, it will be the same thing. So these are the given values here. And the very first step, step 1, we need to describe the fluid. So the first step is what? Fluid description, right? For fluid description, we need to identify the flow type and the fluid type. So that's what we will do. So the flow type, steady flow. The reason we are saying steady flow, the first thing is this is our assumption that for fluid mechanics class here, we will not use any unsteady flow. That is one reason. Another one is, if you look at all the given values, they didn't say anything about like time, like after 5 minutes, the velocity is changing. After 10 minutes, the velocity is changing. So there is no change in anything with time. That means everything is steady here. That's why the flow type is steady flow. And the fluid type, can you tell me what will be the fluid type? What is the fluid here? Water. It's not mentioned directly, but if you look at the very last sentence, ignore the weight of the water, we kind of know the fluid is water. At the same time, if you look at the density, it is actually water, but it will be given to you. You don't have to spend that much time to identify what is the fluid. So fluid type is water, which is incompressible and inviscid, like viscosity is very, very small, almost 0. Okay, that is the step 2. Now for that is step 1. For step 2, what is the step 2? Control volume and free body diagram. So control volume and okay, this step is actually the most important step. If you can do this step properly, the next part, the calculation will be easier. So here we will identify what are the available forces, what are the directions and everything. Okay. So make sure you understand that. We will spend as much time as we need for this step. Now, for your copy, you have 2 of this picture, right? This one. So one we will use for the control volume, one we will use for the free body diagram. You should have the caption under each one. So use the right one. So for the control volume here, what I will do, control volume is we need to identify which volume or which area we will consider for all the calculation, which is easy here. We will just take the total shape of this valve, that is the control volume. Okay. Now I will do one more thing here. For control volume, I will also identify all the velocities, direction, and the components. Okay. So how many inlets we have here and how many outlets we have here? One inlet, what, two outlets. Okay. So this one is the inlet, right? Like 20 CFS. Okay. So here that was V1 and two outlets. That means flow is going outside. That is V2. That is V3, right? Now, for momentum equation, linear momentum equation, we always need to work with like X direction and Y direction here. So at first, I will decide which side, which direction I will consider positive. So X plus Y, that is the positive Y direction. Okay. Now, can you see that V2 and V3, they don't have, like they are not aligned with X or Y direction. So what we need to do? We need to take the components in X and Y direction. That's what we will do. If you have different color, you can use that or use some different type of line so that you will not get confused. Okay, so here what I will do, I will find the component in Y and X direction. Okay, here. So what will be the X component for V2? Cosine 45. Okay, and this one will be V2 sine 45. What about V3? It will be V3 cosine 60, and this will be V3 sine 60. We don't need to do anything for V1 because that is already aligned with the Y direction, right? Okay, so this is our control volume diagram. Oh, not control. Okay. And are we done with this one, everyone? Okay, so we will start working with the free body diagram right now. Okay, so this one is the free body diagram. Okay, vector free body diagram. That's why there is a line on top of free body diagram. Okay, so for free body diagram, can you go back to your this this page of your lecture and tell me what are the different type of external forces you can have? What is the very first one? Resultant normal force, and the second one is resultant shear force. And we also told that it is kind of difficult to identify the normal and shear force differently. So we will consider those two forces as just one resultant force. So that's what we will do here. What I will do, I don't know anything about this resultant force. So you can use any direction like positive, negative, that doesn't matter. So I will just doing in that way. That if P W X this is just arbitrary direction I use because I don't know. So from the answer, I will know whether my assumption was correct or not. So I will just write down what is that. If PW is actually force of pipe on the water, okay, which is the resultant force. Okay, so that's what we will try to find. That is one thing. Okay, now the other type of force was what? What was the number 3 type of external force? From this one, we are done with number 1 and number 2. Number 3 is the pressure, right? In and out that acts on open control surfaces. Now, if you go back to this table, we know the pressure at every point, right? But are you seeing there is a negative sign for 46 here and positive sign for 1 and 2? So what does that mean? Positive means just the normal thing. Like when we say something is pressurized, what does that mean? Like we are pressuring like this way, right? So since we have the positive pressure for point 1 and 2, it will be something like that. The point 1 and 2 is pressurized from outside. That's why it's the positive. Okay. And what about point 3? It's the negative pressure. That means pressure is going outward direction. From the given values here, you see 14, 13, 37, and 46. So another way can be, we can consider everything positive, and when we need to use the value, we will just use the negative value. How does that sound? Maybe that one will be less confusing, right? So let's use everything positive here, and we will take care of that when we will write down the value. Okay. So due to pressure, you will have the pressure force, right? So let's write it down. Fp1 equals to P1 A1. Fp2 equals to P2 A2. This one, right? Again, we need to know the X and Y direction. This one. And you can see again for FP2 and FP3, we don't have the X and Y component right now. So what we need to do? We need to take the components, and that's what we will do right now. Maybe I will use the black color. Okay, so this one will be P3 A3 cosine 60, P2 A2 cosine 45, and P3 A3 sine 60, P2 A2 sine 45, right? Okay, so now we have all the different type of external forces here, and we know the components also. Now the calculation part, if we can do a good job for this step, the step 3 is kind of easy because now we just need to write down the equation. But are we good up to this point? You got the idea how to work on that. If not, we will explain again and we'll spend more time on that part. But everyone, confirm me that you got the idea how to work on that. Okay, good. Now let's work on the step 3. And for step 3, what we will do, at first we'll write down the equation. Everyone's done with this one? Okay. So step 3, what we will do, what is the step 3? Linear momentum equation or linear momentum calculation. So I will just write down that. Okay, and the equation was summation of F, summation of V rho this one. Okay, summation of F, we have 1 inlet, 2 outlets. So at first I will write down this way, V rho outlet minus inlet, right? Now, the reason I asked you to draw 2 diagrams, one is for control volume and one is for the free body diagram. What we will do for this part, we will use the free body diagram. Okay. And for this part, we will use the control volume diagram. Okay. So I find it easier to split that into 2 parts so that I don't have to, like I will not get confused with this part. So because free body diagram is all about the external forces and this summation of F is actually the external forces. So we will use the free body diagram for the external F and we will use the control volume diagram for this one. Okay. Now you are in better position because you have everything on the same page and I have all the diagrams on different slides. So I will just do back and forth. Okay. Everyone's good up to this point? Okay, so let's start working on that. At first, we will work with summation of force, use free body diagram. Okay, so what are the different, this is the free body diagram. In X direction, what are the forces we have? And so we have this one, we have this one, and we have this one, right? These 3 in X direction, everyone? Okay, and all of these are in negative X direction. So much negativity in one problem. Okay, so I will write down this one. Summation of F equals to P3 A3 cosine 60. Oh, is that P3? I'm sorry, that P3 is positive here, right? We will work with the sign later, but at this point it's actually in positive direction, right? Here, you see, yeah. Because I think that would be less confusing for you. So P2 A2 cosine 45 and FPW X, right? Okay. So what is the value of P3? Negative 46 and A3 is 0.19635 cosine 60 minus P2 is 1337 multiplied with, from where I'm getting all of these values, PA, it's actually given. So from that point, I'm doing that. I don't know anything about PW, so I will just keep that as it is. So what you will do, you will give me the number for first two terms, okay? That will be unknown here because I don't know. That's why I just kept as it is. That is the final thing we need to calculate actually. Everyone, please do the calculation, and if you do the calculation properly, you should get something around 750 exactly. But it should be something.
Negative 747.
Negative 747. Anyone else got that number? Check that again. That is not close to 740, 750. That should be the number, negative 747 point something, 0.03 or something like that. That's what I got. Okay, so check your calculation again and make sure your calculator is in degree form, not in radian. Okay, so that should be negative 747 point. So in my undergrad, we had one course, it's called the numerical methods in like engineering or something like that. And we had to do like lots of calculation in radian and degree, something like that. I had very good preparation and I went through the test. I knew everything, but I couldn't, like it was like you need to do calculation, repetitive calculation, and till you get the zero residual or something like that. So I knew all the questions, but I couldn't get the answers. And like obviously I didn't do well. Right after the test, I realized my calculator was in radian. It should be in degree. And that's all the calculation was wrong. Yeah, that was a 3-credit course, I guess. Okay, so this is the number for summation of F. Now we will work with this part, like control volume diagram, that part. Okay, so let's do that one. Summation of V rho VC. Sorry, that should be FCS. At first, we will do the X direction, then we'll do the Y direction also. Okay, so for this one, we had, what was the equation we had? Outlet and inlet. Okay, that's what I will do. V rho outlet minus summation of and we have two outlets and one inlet, so we need to write down in that way. So what are the numbers for the outlet? 2 and 3, right? And this whole thing can be counted as Q, because that was a scalar quantity. If you can remember, Q equals to AV. So that's what I will write down. Q2. Q2 plus V3X rho Q3, that is the outlet. And for inlet, it was just V1 rho Q1, right? Now, since we have a good control volume diagram, we will find out the values from that diagram and the direction also, okay? So for V2, what was the component in X direction and what was the direction for control volume diagram is this one. So that is the V2, right? Is that positive or negative direction? And for V3, and do you think there is any component for V1 in X direction? Good, at least some term is 0. Okay, so here for V2 is positive. That was V2 cosine 45, I guess. Rho was 1.94. What was the Q2? 12. What about V3? That was negative or positive? $1.948. Okay. And for V1, we don't, okay, I should write down V1X. There is no term for V1X, so 0 multiplied with rho, this one, okay? Are you good up to this point, everyone? Okay, so I will go backward and do one thing. I will name this equation as equation number 1, okay? Now you have summation of F and summation of all of these things. Can you equate these two sides and find out the unknowns for X direction? Name that equation as equation number 1, okay? Okay, now you have everything here. Just write down from equation 1, 747.03 minus FPWX equals to, oh, we didn't calculate that number. What is the V2 value? V2 is 15.3, right? Is that correct?
Yes, ma'am.
Okay, 15.3. What is V3? 40.8. And we don't have any V1, so I don't need to use anything for that. 40.8. And this whole term is 0. So what is the number you got from this side? Let's check what I got. This one. What number you got? I got something negative 64. Let's check if I write down everything properly. Yes, 15.3, 1.94. Yes, that is correct. Negative. Yes, you should get negative 64.747. Right?
Yeah.
So negative 64 point, something like that. Okay. Do that and everyone's good up to this point? Yes. This one will be pounds because we are working with the like force. So you can write down pounds here. An FPS system, that's why it's pound. Okay, so that should be equals to negative 64.747. So if we check that on this side, so it will be okay. What is the answer right now? 682.28 or something like that, right? Now, negative means our initial direction assumption was wrong. We considered that the force will act in this way, but that is not correct because we are getting the negative sign. So what I will just do, so that was our initial direction, right? So finally, it should be 682.28 lbf. That should be the correct direction. Okay, that means (682.28) lbf. Okay,
That's 64.747.
that should be in
Or
pounds because everything is yes, that's correct. So x direction is done, y direction is exactly like that. The repetitive calculation. We have 5 minutes, we can start working on that, and obviously we can't finish that today, so we will work on the rest of the part on Friday, I guess. Okay, so let's work on that. And this time you are a little better in understanding all of this because we did one part. So I will go through very quickly, and I didn't keep any space for y direction. So I will add some space here. Okay. Y direction, summation of Fy equals to B Y. Okay. And again, we have two outlets, one inlet, so it should be V rho outlet Y, maybe Y direction. Okay. Okay, again for Fy, we will use the free body diagram. And for this one, we will use the control volume diagram. And this is equation number 2. Okay. So let's calculate the Fy first, okay? So in Fy direction, I need to go back. This one, we have how many forces working on Fy direction? This one, and this one, right? And this one. So now we have 4 different forces in Y direction. P2, P3, negative, negative, P1, and PP, positive. Okay. So we have P3, A3, sine 60, P2, A2, sine 45, plus P1, A1, plus FP, WY. Is that correct? All of the terms? Summation of, okay. So P3 was negative 46. A3 was what?
Negative.
19635. 0.19635. 19635 sine 60. P2 is 1337. 17854. Sine 45. P1 is 14. A1 is 1. Okay, I will just complete this line and I will stop at that point. 7.2. Okay, so we will start from this point in next class. Make sure you bring this class example and your class lecture on Friday. Okay. Thank you, class. You have a good day. I will see you on Friday.